Okay, so let's take a look at the payment function in Excel. So I'm going to go through this pretty quickly because it's a video and you can pause it and watch it again. But what we're really going to look at is the present value, the rate, the number of periods, and the payment function. And in Excel, if you know the value of any three of these, you can always calculate the fourth one. So let's say, for example, we want to have a loan, want to take out a home loan for $100,000. The bank is currently giving 4% interest rate, and the term of the loan is 30 years. Okay, suppose we wanted to calculate how much do we have to pay at the end of each year. So this is a strange way of doing the calculation. Most banks will not let you pay once a year, but we're going to use the Excel function because it's simply set up for this. So if we were to make a payment at the end of the year, the way we'd calculate how much we'd have to pay each year, we would type in a formula saying equals PMT, which is payment. And the first parameters you can see right here is the rate. So the rate we have in this box, which is 4%. Now we're calculating this based on making a payment once a year. So the rate for the year is 4%. Then the next parameter is number of periods. How many years are there going to be? And in this case, we're saying the number of periods is 30 years. Okay, so now in this formula, we have the number of payments is 30 years. And then the present value of the loan. What is the loan in today's dollars? Not what is the loan 30 years from now with interest. So in today's dollars, it's D4, which is $100,000. So you hit enter and it calculates it for you. If you paid $5,783.01 at the end of each year for 30 years, you would end up paying off this loan. And if you were curious to know what was the total amount of money you pay, you can take the amount of money you pay, the $5,783.01 per year, times 30 years. That's the total you would have paid. So you would have paid $173,000 over 30 years to pay off this $100,000 loan. Now, the reason I did this is not that common to use payments at the end of a year, but that's exactly how the formula is set up. What's more common when doing a home mortgage is the bank would like you to make a payment at the end of every month, not at the end of every year. All right, so little adjustment to the formula. That little adjustment to the formula is if you wanted to know how much you'd have to pay at the end of every month for 30 years, then the formula would go, the first field we have to fill in the payment function, the first parameter, is the rate. But the rate the bank gives you when you walk past the bank and you see the rate in the window on a poster, that's the annual rate. But we want to know the monthly rate. So since there's 12 months in a year, and this isn't really perfect because not every month has exactly the same number of days. Some have 28 days, some have 31 days. But this is the way Excel is usually used to calculate loan payments. And this is what the banks will do too. So you take the number of years, which is in box D5. I'm sorry, you take the percentage, the 4% per year, and you divide it by 12 because there's 12 months in a year. So 4% divided by 12 would be the monthly interest rate because we want to put in the interest rate for the time gap of the periods. So if we're doing a payment every month as opposed to a payment every year, we want to use 1/12 of the interest rate. Now the question is, how many payments are there? How many periods are there? Number of periods. Well, now it's no longer 30 years. It's not 30 payments, which is once a year. It's 12 payments per year. So it's actually 12 times 30 years, which is 360 payments. So it's 360 payments, but for a lot smaller interest rate between each month. And then the original value of the loan is also the same, the 100,000. So if you're making a payment every month, then you're making a $477.42. Over the course of 30 years, you're going to pay a little bit less money. And the reason why the person paying monthly pays a little bit less than the person paying annual is because of compounding of interest. Okay, now if you look at this formula, not this formula, the payment formula, there's a future value and a type. And I'm going to talk about that towards the end of this lecture, but I'll just say it right here. The future value by default defaults to 0. So in other words, at the end of the 30 years, the amount of money you owe or is owed to you is 0. You're trying to zero out the loan. You have the option to set it to a different number, and we'll talk about that later. The second parameter, the type of the loan, 0 is by default mean it's paid in arrears, which means you make the payment at the end of the period. So when you get a car loan or a home mortgage loan, you usually make the payment at the end of the month. You could set the type to 1, meaning you make the payment at the beginning of the month. And that could be kind of like when you're paying rent on an apartment, you usually pay the rent at the beginning of the month. And then you could do these combinations. Maybe we'll take a look at one towards the end, where you pay rent on an apartment, then after a certain amount of time, you become the owner of the apartment. And that's where the future value may change. Okay, so now going to calculating the present value. What I'm really doing here is that the yellow boxes, or these tan boxes, are the boxes that we have the data for, and the green box is the one we're trying to figure out. So if we know the bank's giving 4% interest, and we know the term of the loan is 30 years, and we know the monthly payment. So you might think, why would you know the annual rate and the number of the term of the loan and the monthly payment, but not know the loan amount? Well, let's say, for example, you have a budget and you can right now only afford $477.42 per year. Then you might say you walk past the bank and they have a loan for 4%. You'd like to get a 30-year loan. And now you want to buy this house and you want to know how much of a loan could I get if this is all I could afford per month. So the formula, I'm going to click on this box. This is the box with the formula in it now. And once again, now we're getting into the habit of dividing the interest rate by 12 and multiplying the number of years times 12. So when you want to calculate the present value of a loan, meaning you're going to make this series of payments over 30 years, you're going to pay $477.42 per month for 30 years. And the interest rate the bank is charging you for that 30-year period is 4%. How much can I borrow? How much money can I borrow? What's the present value of my loan with these parameters? So again, we have the rate. We're going to do the annual interest rate divided by 12. That's the monthly interest rate. Number of payments. That's the number of years times 12. Number of years times 12. And then once again, the monthly payment is down here. And again, we have future value and type of the loan. So this basically tells us if you pay $477.42 for 30 years at 4% per year, but you pay it at the end of every month, you could borrow $110,000. Okay. Now, suppose we don't know what the interest rate is. We know how much we want to borrow. We know how long the loan is, and we know how much we're going to pay every year. And you just happen to be curious and say, what is the interest rate? This might come up if you're comparing interest rates from two different banks. You want to know, what is my interest rate? If I made the same payment at a different bank, what would the interest rate be at that bank? So here's the formula for the rate function in Excel. It takes in, so all of these functions, present value, rate, number of payments, and payment itself, number of periods and payments. Each one is a function that takes the other three as input parameters. So if you want to know the rate, it's the number of periods, which is the number of years times 12. So that's how many payment periods there are. How much payment do you make every period is 477.42. And then we're going to take the loan and the rate itself. This would calculate a monthly rate. So we'd multiply that by 12, the product of the whole thing by 12 to get the annual rate. Okay, and then the number of periods. If you knew the present value of your loan, you knew the interest rate and how much you're going to pay every month, you might want to know how many periods there are. So if we knew D5, if we knew the rate, the first parameter, that the function number of periods. So this would kind of be, if you knew what the bank was charging for an interest rate, you knew how much you could afford every week. I'm sorry, every month. And you wanted to know how long is the loan going to last. In other words, if you put a little more money in, can I make the loan end sooner? So to calculate the number of periods, we're going to say, we're going to take the interest rate, the annual interest rate, and divide it by 12. That's the monthly interest rate. So the interest rate of a period. We're going to take the present value of the loan. That's the second parameter they want. And then the present value, and that, sorry, the payment of the loan. The payment is the second one. This one, how much you pay each period. The third one is the present value of the loan. And then if we take that whole thing, divide that whole thing by 12, we get the number of periods for the, I'm sorry, let me go back to that. This would be the number of periods in the entire loan. If we then wanted to calculate how many years that is, we would divide that by 12 because there's 12 months in a year. So it'd be a 30-year loan. Okay. Now, if we didn't have Excel to do this with, we could write out a big table and amortize the whole loan. So let's say, for example, we know how much the loan is. We know what the annual interest rate is. We know what the periods are. And we know what the monthly payment is. And we wanted to just track the loan. So suppose we now track the loan. And we said the loan starts off at the beginning of the month, at the very, very beginning of the loan, the very, very beginning of month number 1. The loan is for $100,000. Every month, at the end of the month, we're paying $477.42. The interest of that loan is equal to how much we owed at the beginning of the month times this interest rate divided by 12. So it's really how much you owed at the beginning of the month times 1 month worth of interest. That's how much interest we owed at the end of the month. So if we owed $333.33 at the end of the first month, and we made a payment of $477.42, the amount at the end of the first month that got subtracted off our principal was $477 minus the interest. That's how much we put towards the principal. And then our new balance at the end of the first month would be the original loan value at the beginning of the month minus the amount of principal we paid off, not the interest, but the principal. So now the new value of the loan at the end of the first month is $99,855.92. Now this is the value at the end of the first month. At the very, very beginning of the second month, which is the same thing as the end of the first month, that happens at the same instance, midnight, the night before the month starts. So this value should simply be this value. So this box is just the previous row over here. Then we just do the same thing over and over. And we do this for 30 years times 12 months, 360 payments, and our loan balance eventually hits 0 at the end of 360 months. So this is the way you'd solve it if we didn't have these tools. You could just calculate these numbers down. So like I said, I just wanted to go quickly through those. What I said I wanted to cover, I said I'd cover it at the end, was the future value parameter. So suppose, for example, I wanted to have at the end of, so I'm paying this much per month, $477.42. So remember that number, $477.42. Suppose I wanted to calculate the payment, but so I have my rate, my monthly rate, because I divided by 12, my number of periods, which is number of years times 12, and my original principal. But now suppose I wanted my future value of the loan to be comma. And so normally at the end of paying off a $100,000 loan at the end of 30 years, the value of the loan is zero. You retired the loan. Let's say for some reason you wanted it to be worth $20,000. So now I'm saying the future value of this loan is $20,000. Okay, so what would that do? It made my payment go up to $506.23. So it's at $477, whatever, and now went to $506.23. Let me go to this amortizing, and suppose I change this to, what was the number again? I forgot already. 506.23. Suppose my monthly payment was, and that's a negative, 506.23. So that changes all my numbers. So now I started off with a $100,000 loan. I'm paying $506.23. The first month is $333, but now I'm paying off a little bit more of the principal. What this really means, because I'm making a bigger monthly payment, I'm going to pay off the loan sooner than 30 years, right? Because I'm paying off the loan sooner. But now, where are we? Right around, instead of 360 payments, around 332nd payment, the loan was paid off. Then I started building up equity, and I actually built up to $19,998. So what I'm basically doing is I'm paying a little bit higher than I needed to for this loan. And at the end of the 30 years, the bank now owes me $20,000. Right? So that's really what I did in this formula. I basically said, I want to have my loan, I'm putting in my rate, my number of payments, and the present value. Now, this next parameter that was optional was future value. That's what I want the value of my loan. I want it to be $20,000, which is kind of unusual. But sometimes there'll be apartments. You could be renting an apartment and the landlord will have a deal where you pay rent for a certain period of time and then you become the owner. And so the landlord wants to charge you more than just the normal rents. They want the present value to be some number that they believe is equal to the value of the home at the end of the term of the lease. So then you could calculate how much you want in that amount. You could also put in a negative number. So let's say, for example, you had a car loan. Let's make it a little bit more realistic. Let's say you had a car loan for $40,000. And then you wanted to, at the end of the car loan, you don't want to pay off the whole loan. You want to pay off like most of the loan. Like I say, if you leave the future value out of default, it assumes you're trying to pay off the whole loan at the end of the loan, at the end of the term of the loan. But let's say we put in a negative number like $15,000. So now what we're really doing is we're saying we're borrowing $40,000 at 4% for 30 years. Well, let me change this. A car loan's usually about 5 years. All right. So, so what we're doing is this: we're borrowing $40,000. Let me first take this out. Negative 1,500. Okay, so if you borrowed $40,000 at 4% for 5 years, every month you would pay $736.66. At the end of 5 years, the car would be completely paid off. But now suppose you decided to use the future value thing. You say, I don't want to pay off the whole car. I want to just pay off like most of it. So I'm going to leave a balance of, let's say, negative $15,000. I'm going to leave $15,000. So now I'm going to pay less. I'm going to pay $510 a month, as opposed to, what was that again? 700 something, 736. Okay, so I'm going to pay $510 a month. I want the net value of my loan to be negative $15,000. So I'm paying $510 a month. What that basically means is at the end of my 5-year loan, I still owe the bank $15,000. Now, why would I want to do that? Well, I like the idea of having a lower monthly payment, but the downside is I still owe money to the bank. But maybe I got one of those Kelly Green books that tells you the value of a car, and 5 years from now, I think the car is going to be worth about $15,000. So as long as my trade-in on the car is worth the balance on the debt, I'm not going to worry about it. So you might want to use, the idea is basically, when using the payment function, you have the option, this parentheses is an option, to add in the future value. That's the value of the loan at the end of the period. 9 times out of 10, the value of the loan at the end of the period is 0. You paid off the loan. That's usually your goal. And like I say, the type of the loan also is, the default is you pay at the end of the month. Home mortgages, car loans, they're usually paid at the end of the period. But then things like paying rent is an example of something that's paid at the beginning of the period. So then you would put a 1 there instead of a 0. So that essentially means that you are paying at the beginning of the period. Okay.